So to continue this conversation, the second part of the day will focus on a from ideas to action emphasis in the title of the symposium. And for this reason, I could not imagine a speaker better positioned than our keynote speaker today to really get us to move forward in this conversation, Dr. Danielle Wood. Dr. Wood serves as an assistant professor in media arts and sciences and holds a joint appointment in the Department of Aeronautics and Astronautics at the Massachusetts Institute of Technology. Within the Media Lab, the MIT Media Lab, Professor Wood leads the Space-Enabled Research Group, which seeks to advance justice in Earth's complex systems using designs enabled by space. She is a scholar of societal development with a background that includes satellite design, earth science applications, system engineering, and technology policy. In her research, Professor Wood applies these skills to design innovative systems that harness space technology to address development challenges around the world. Prior to serving as faculty at MIT, Professor Wood had positions at NASA headquarters, NASA Goddard Space Flight Center, Aerospace Corporation, Johns Hopkins University, and the United Nations Office of Outer Space Affairs. And with that, it's my pleasure to invite to the podium Dr. Danielle Wood.
Thank you so much. It's wonderful to see this room full, and thank you all for being here, especially to the students. How many of you are students? That is amazing. Welcome, and I've definitely welcomed students of all ages, but especially those who are from Framingham State University. I'm so glad to be here with you today, and thank you for joining. Now, for those who were here earlier, I have a special treat to follow on from the talk by Dr. David Kendall. He explained, for many of us, that the Committee on the Peaceful Use of Outer Space is a United Nations committee in which right now about 92 countries gather several times per year to ask what are the most important questions addressing our world and how we decide to operate as countries and as organizations in space. Today we have a special treat, which is a preview of the 2025 meeting of the Committee on the Peaceful Use of Outer Space. They are debating an important question, and as you heard in the talk earlier, if you were here, the countries must come to consensus to make decisions that will affect all the countries operating in space. I'm pleased to have with us today representatives from the country of Liberia, Juliana, and from, Sue's from Liberia, as well as from Ghana. And we are debating right now, you'll hear their views on an important question facing the committee. A motion has been put forth to determine whether we should zone locations on the moon. One idea is actually to zone the entire moon as a park for recreation and cultural enjoyment. Another idea is to include areas on the moon where companies can operate in industrial activity. We're going to now hear the views from Liberia and Ghana on this issue. Representative from Liberia, please start.
Okay. Hello, everybody. My name is Sue, and I'm representing for the park. And I believe that we should be able to form a park on the moon, because it's like something like describe Disneyland. That's a place where a lot of people want to go, and it sparks interest in many people because that's a place where you want to go and have fun. And just like the moon, that's somewhere where it could make other people interested in wanting to go there because it's a park, and it's not just going to spark little people's interest. Like younger people, it could make them interested in stuff like the moon and want to be educated on the topic because it's a park, and it makes them want to learn and have fun in the same way.
Thank you very much. Representative from Ghana.
Hello, my name is Juliana, and I think that we should make the moon into like a place for enterprises, so like they could make like mines and things, because eventually the earth isn't gonna last forever and we need like supplies and things, and so we could get our materials that we eventually won't get anymore from earth, from the moon, to help sustain everything. So yeah.
We can see there are many important issues to consider in this question. I know the delegates will be continuing to debate and negotiate this topic. Thank you so much for sharing your views. We appreciate it. Let's have a hand for our representatives. Sue and Juliana and some of their colleagues. If you don't mind standing up, we have a number of ladies here from the Girls Inc. program and from a local charter school. So thank you for being here. They're 7th graders. It's one reason to celebrate early dismissal on Fridays, that they can come join us. So today, I'm happy to share with you some of the work of the Space Enabled Research Group, which I lead. It was founded in 2018. And along with a number of graduate students and researchers, we are asking an important question, which is, can technology from space and the human pursuit of space activity help improve both life on Earth and our future societies in space? Our mission statement asks the question, can we advance justice in Earth's complex systems using designs enabled by space? Now, justice is a big and important concept, and I don't claim to have fully understood it. But we have several ways we define what justice means for our daily work. The first question asks, who's involved with space? As we can see, I asked the young ladies which countries they wanted to represent. In our dialogue and our simulation of the future committee meetings about space policy, they chose the countries of Liberia and Ghana. Countries throughout Africa and Latin America and Southeast Asia and Eastern Europe, really every region, play a role in helping decide future space activity. And many of them are starting new space activity because they view space technology as core to their future. The other side for justice is to ask, what kind of future are we creating in our Earth? And we've heard earlier from Dr. Kendall, and I'll repeat references throughout my talk, one of the ways we can measure whether we're making progress toward a safe and sustainable world for everyone is the Sustainable Development Goals. How many of you have heard of these goals before today? That's encouraging, especially for the students here. If you've not seen these before, please go Google search UN SDGs. That's all you need to find it. And I want you to pick one of these goals and make it your personal mission in life. Because we need everyone, but especially the students who are our future leaders, to pick one of these, because it's going to take your whole career to work on this. So you have a job that can last for a long time. Whether it's looking at water quality and access to clean water for everyone, making sure everyone has access to clean energy and healthcare. These are massive societal problems that require many different kinds of disciplines. But space technology is one of the tools we can use. And it's part of my mission to make sure that I, as an aerospace engineer working on development, bring all the tools that I'm aware of to this issue. Now, there are 6 types of space technology that I've identified through my career. You've heard I've worked in a few places. I was basically collecting knowledge about these different topics. And the goal here is to say, how can these existing space technologies be used more effectively to help support the Sustainable Development Goals? Plus, of course, we want to invent the next generation technologies that we may need. Satellite Earth observation. It just means we use satellites that orbit the Earth to take measurements about the environment and the atmosphere, measurements of the ocean and of the land. I'll show you a few examples. Satellite communication and positioning. They're tools that you use in your daily life without even thinking about space. But if you're using a cell phone, you're using space-enabled technology. The satellites are telling you where you are, so you can use your maps. That's how I got from my home to here today safely for the first time. And also, often when you're making international connections, whether it's through a radio broadcast or TV, or whether you're calling internationally, you might have an internet search or a call or a presentation that's routed through a satellite before you even know it. Now, there's several other areas of space activity: human spaceflight, the transfer of technology from other fields into space, as well as fundamental scientific research. All of those may sound like they're just done for technology and for science, but if we transfer the benefits of those activities into societal issues, they can also play a role in supporting the SDGs, so I'll show you about it later. Now, on my team, we're asking the question, who needs to be involved with using space technology and designing it so it really makes a difference for sustainable development? We bring together in our team 6 different areas. It's not everything we need, but we know we at least need this diversity of thinking. We include design thinking, which comes from engineering, from business, from art, but we're asking, how do you design something while listening to those who are going to be affected by it, such that you can actually use it in a way that meets a need at a very local scale? We practice art, and some of my students and team members are artists, and they think of their work partly as practicing what it means to be a human by creating art that helps us dialogue about key issues. We draw from social science. How many social scientists do we have in the room? Those from humanities, thank you for being here, and we consider a vital partnership with you, because before I want to do a project, which may be a collaboration with a development leader in a country around the world, I must learn from a social scientist. I must read some history. I must draw from some methods from anthropology to be a better listener. We cannot do effective engineering and science without collaborating with you. So thank you for being here. My training is mainly in engineering, although I've made a point to always be learning social science along the way. But I've learned especially aerospace engineering. I work a lot with computer scientists and earth scientists. And the other idea you see here is complex systems. This is an area we can all grow in. We can all use systems thinking to understand how an action we take is part of a bigger network. These are all part of the tools my team uses. I want to highlight that in our work, our goal is to ask how we can apply space technology directly to needs, but it's at different scales. So we talk to development leaders, which could come from the United Nations or from national governments, from regional organizations, and from local companies and universities. I'll show you cases of our projects at each of these scales. Development and meeting the sustainable development goals is everyone's job. And so we see leaders working at all these scales on these SDGs. And the question for us, and this is a picture of my team, showing the researchers, the graduate students that we're collaborating together. And you can see we come from lots of different backgrounds, both in terms of our academics and our family lives, our languages. We're asking constantly, how can we be better partners to development leaders who will be making the difference in their own countries, and some of whom are also the researchers and scientists thinking about how to expand work they do in space. I'll give examples from several of our projects, but first, I want to reflect on the word sustainability. And here I want to highlight the zones that we might need to think about in defining what sustainability means. The idea here is that sustainability happens at every scale of human activity. In this case, we can say sustainability is just asking, when humans impact location, are we leaving it better or worse due to our activity? So at every location we're operating, we can ask, how has our impact led to progress or perhaps to concern? What you're seeing here is actually a view of the global oceans generated by a computer, but based on data from satellites. So NASA operates about 20 satellites that orbit the Earth and take measurements, but also partners at other organizations around the world in Europe and Japan and India and Brazil and many places are also collecting data, and much of the publicly funded data is shared freely. So here's an example of a computer simulation showing the global temperature of the ocean. Therefore, we can understand the currents. We can see something about when you study long-term temperature changes in the ocean, it's one of the key drivers of climate change. It's also a key driver of near-term weather. So if you want to ask, is it going to rain? One of the questions to first explore is what's happening in the temperature of the ocean. But of course, our global oceans are facing a crisis of sustainability. Humans have done many things that are damaging in terms of how we dump waste into the ocean and also how we extract life from the ocean. So this is one area where there's a crisis of sustainability. Another area is the question of biodiversity. This is a view of biodiversity from space. Wherever you see green here, these are satellite-based observations of life in the form of plant life, both on land but also in the ocean. So biodiversity is another sphere in which we need to ask, how are humans impacting and often damaging the biodiversity and sustainability in that era? Another zone to consider then, of course, is the question of the atmosphere. So this is a view of satellite measurements taken from a variety of countries, about 9 different satellites. You have some operated by the US, by Japan, by India, by France. We have such great computers now, we can, on a daily basis, combine rain and snow measurements from around the world, and there's videos like this online every day, looking at rain and snow from the last 6 hours. Of course, the atmosphere is another zone where we have a crisis of sustainability, especially considering the rising amount of CO2 in the atmosphere as a result of human activity. So we have a sustainability challenge in the water, on the land, on the atmosphere level. And many of us think about this as we think about today's climate strike. This is what people are generally asking. How are we going to address this long-term concern? This particular simulation is a combination of satellite-based data and other scientific measurements. And it's put into a computer where scientists who are atmospheric experts are estimating the behavior of the atmosphere. They can do it so well that this is looking backward in time and able to actually correctly predict in their computer simulations real hurricanes that we know happened, because they understand how the dust and other objects floating in the atmosphere are impacting our weather. So scientists gain a lot of their knowledge about these features from satellite data, but mixing it with data from the ground and with mathematical models. Hope I answered your question from earlier. He was asking, well, what do we learn from these satellites anyway? So I was like, I think you'll see it in a minute. So I'd say these are all zones where we know we have crises of sustainability. I want to add 2 more because we have more challenges to address. We also want to then consider the orbital environment around the Earth. Again, I said, wherever humans are operating, we tend to create a crisis of sustainability. And the question of sustainability is, can we continue to operate there, or will we actually destroy the very thing we want to enjoy? I mentioned earlier, we're using satellites for communication, for Earth observation, for entertainment, and for positioning services, and for science. What you're seeing here is a model from a video, but it's showing pretty accurately the scale of satellites we have. About 2,000 useful satellites over the Earth, but about 20,000 large objects over the Earth, many of which are either trash from old satellites or rockets, and some are natural objects, but most of this is human-made. We're putting so many things in space that soon our new missions we hope to put up will be in danger of hitting other objects, making more trash, and therefore making it very dangerous to operate in space. We must and we can take action right now to reduce this crisis, because we want to continue to enjoy sending humans and useful objects to space for decades to come. Now, these are areas where humans have been operating for decades or centuries. What about the next places we want to go? This is an image from NASA showing Mars. There's not a lot of human debris on Mars yet. There's some, because we do send missions there and leave them. As we prepare for a future in which humans will have more activity on the moon, on asteroids, on Mars, I don't want us to repeat the same pattern we've seen in the ocean, on the land, in the atmosphere, in orbit around the Earth. It's not too late for the moon and Mars for us to put in place better ways of operating as a people group, as a society, but we have to take action. We have to do it actively. If we keep our same typical way of operating, we're likely to see the same problems on Mars that we've seen basically in Earth orbit, where everyone did what they felt would be interesting for their national missions, but we didn't have a cohesive view. So one of the things we need to call for is global dialogue. That's why I invited our 7th grade friends to start. It's not too early to ask what should be the ways we sustain our human activity, whether it's in the ocean, the atmosphere, in orbit, or on Mars. We start one step at a time, so I'll show you some of those steps we're taking. In our team, we do research in 3 areas. We first ask, how can we design new space systems that are both accessible and contribute to sustainability in this broad sense? We identify opportunities to design space activity, particularly for the SDGs, usually in partnership with a particular development leader. And finally, we do fundamental social science research to ask, what's the link between technology and justice? I claim in my mission statement, we want to advance justice, but for that, I need to actually spend a lifetime exploring what justice means and how my technology plays a role. I'll give you examples from all 3 areas, and I hope you have questions at the end. First, in the area of designing systems that are both sustainable and accessible. I'll start actually with an initiative we're doing in partnership with a variety of organizations, particularly the World Economic Forum. They are a group that brings together many companies to talk about key issues in our global society, and I have to give them credit because they formed a council of company members, mostly a few government members, and they said, please tell us what are the problems that are coming up in the space area that we should work on. And they had the foresight to say that one of the key issues is due to the orbital debris in space and the fact that more companies want to put more objects in space. So we've invited a team to compete and be selected, and we were one of the teams, to work on a project called the Space Sustainability Rating. So earlier we heard about the COPWIS, the United Nations Committee. They are doing important work in this area. We are also joining the work from the private side. So as I showed, we have many objects in space. It's exciting to have them, but of course, a lot of it's not useful anymore. In fact, we either need to recycle it, reuse it, or somehow get rid of it, but also reduce our future production of space debris. There are a number of companies that have interesting ideas that are technically very fascinating. They'd like to put a lot more satellites. I mentioned about 2,000 now. There are companies individually that want to put thousands of new satellites, as many as 12,000 I've heard. These are all plans just for their own mission to provide more internet access and more connection for phone connections and broadcasts, which would be lovely, but we will have to ask the hard question of how do we ensure we don't make it more crowded in space and more risk for operations. Our team is working with the World Economic Forum, the European Space Agency, the University of Texas at Austin, as well as a cool company that does space analysis called Bryce. And we were all selected through the World Economic Forum to create what we're calling the Space Sustainability Rating. This is a non-government activity, but governments can play a role by getting involved and including it in their own national law. The idea is, how many of you heard of LEED? LEED is pretty popular, right? What does LEED mean? It just means if you walk into a building and you see the LEED symbol, it means somebody paid some money to make sure the building had the best possible design to reduce impact on the environment. And when you see that, you just think, wow, whoever owns this building, they might be okay. They might be doing their best. And the idea is actually the building owner paid to have somebody come and evaluate their building to see if they were doing all the things they should, and there's a checklist they should follow. We want to do the same thing for space operators. And it's voluntary, so any company or government or a university, when Framingham State University is sending up a satellite, you too can be rated voluntarily on space sustainability. We'll give you a very clear list and show you if you do these activities, which many relate to the long-term sustainability guidelines we heard about from the UN earlier, you can get a cool score that will make everyone know that you are doing your best for space sustainability. And we're hoping that actually positive peer pressure among companies and governments will lead to people choosing to be rated and therefore choosing to do the right thing to reduce their likelihood of creating space debris. I'm showing a picture matching what David showed earlier. This is actually when we saw the simulation earlier of our 2025 discussion from Liberia and Ghana. These are the rooms where people do meet every year and they debate the question. And so we'll definitely follow all the updates we get from the International Space Policy Dialogue. We'll include those in our space sustainability rating. And that means that we on the private sector side can be engaging and relating directly to the questions that are coming out of the formal United Nations policy discussions. The idea here is we can ask two questions. First question is, what's already in space before you got there? If you want to go somewhere in orbit where many people have already put satellites, we encourage you to think twice about that because maybe it's not the best place to go in terms of sustainability. The second question is, what are you doing with your satellite when you get there? And we mentioned the idea earlier of, is your satellite able to be tracked from Earth? Are you choosing how long you're going to stay in space? Do you have propulsion to actually change your orbit if something's coming toward you? These are all actions that an operator can take. So we're exploring now, making a list and reviewing it with companies, reviewing it with governments. I'm traveling to Japan next week to just go talk to teams there, to companies and government teams, ask their questions, get feedback. We're having a quite open dialogue process to find out what should go into this rating. The rating could then really be used on a voluntary basis to have everybody understand and dialogue about how do we reduce the space debris issue. It won't solve the problem by itself, but we're glad to see government and United Nations and private sector initiatives in this. Another question then is, today's goal is just to reduce the amount of space debris. We'll have another goal. The other goal will be, eventually we'll need to coordinate across different satellites that are going to space. When you fly from London to New York now, this is possible because there's an international body that coordinates among all the different national bodies who are controlling aviation. We figured out some standards for exactly how far apart planes have to be to cross the ocean, and for how do you say, I'm leaving London, I'm coming to New York, so please get ready for me to land. We organized this through an international body called ICAO. We don't yet have the same kind of thing for satellites. So when satellites launch today, groups are generally notifying what's going on, but there's not an international space traffic management system yet. We probably will need one, especially if we have more groups operating satellites. Now, of course, with traffic management, you have different kinds of situations. One of my research team members, named Miles Lifson, he's recently been doing his master's research with me. He's exploring how, just like with cars, you have different zones where you need different kinds of traffic. Sometimes you just need a roundabout where you can just take turns, and other times you need serious managed traffic. And you can think about this also in space, where different locations and different orbits in space have different levels of traffic and different amounts of need for coordination. Our question partly asks, what is going to happen for groups that are new to space when we start to make the rules for future space traffic management? And which voices will play a role in designing it? There's a few countries, the US is one, China and Russia and India. They've produced a lot of the space debris that's there, partly because of our choices and because of our policies toward how we operate in space. So you might say, well, would those countries have a lot of the voice on planning this next generation of technology? One of the goals we have is to ask, can we ask the opinions of countries that are on their way to being involved with space? As I mentioned, in every continent, in Latin America, in the Caribbean, in Africa and Asia, I know the leaders of emerging space activity. So our goal as our research team was to invite them to give us their opinion. How should we design a future space traffic management system? So our colleague, Miles, has done interviews with people from around the world to ask them what are their views. So in this case, we had a chance to talk to people from 13 countries, and I'll list the countries here. And our goal was to find out what are their concerns about the processes that may come in place through both formal UN bodies as well as through informal collaboration. What do they think should be important when we start to set up this new future system? Even if they don't have satellites yet, they plan to in the future, and they might have an opinion about this. We ask questions such as, where do they think we should have the debates, and who should be involved with these early debates? And so we see, for example, their opinions kind of laid out on these different catalogs, and they're highlighting what they think should be a part of the planning for this future system. Another example is asking, what do they think will be important? How will it impact them personally as a country? when we design this? Will they have to lose the control over how they operate their satellites? Will they be invited to share data about their satellites with other countries, and are they comfortable with that? They definitely had some concrete concerns, and these might not otherwise be documented if we didn't have this chance to publish this research. So our goal is to often ask who's not yet involved with space but will be in the future, and what are their views, and how do we design space now for that consideration? Another direction then in that same area is the idea of microgravity research. I'll show you some examples in a bit, but it's mainly asking, when we send things into orbit around the Earth or to travel to the moon or Mars, generally things are moving, spacecraft are moving in orbit around some body, and it means that they're in the state of kind of falling. So gravity is affecting them, but you don't experience the gravity, you get to sort of float. And there's cool research you can do on your body, on plants and animals, and on materials that you can't do on Earth, but works really well in microgravity. My colleague Christine, who just did her master's with us, she asked the question, what will happen when the International Space Station is changing ownership in some way? This is the ISS. It's an amazing location operated by a collaboration of 5 partners with many countries involved. We have the US and Russia, and we have groups from Canada, and Europe is there. And so we have close collaboration. Japan's also involved. And many countries beyond these partners have sent research to the space station, and they can then experience the benefits of microgravity. Here's an example of an astronaut operating on microgravity research. The walls all around inside the station are surrounded by research locations, and many universities can send research there. This is quite open, actually. If you can partner with one of the partner countries, there's often very affordable ways to send research to ISS today, which is wonderful. So eventually the ISS will be somehow transitioned. Right now it's operated by a treaty among these partners, and in the next 10 years or so, they'll change the operational mode. It's also getting older and needs to be replaced or redone in some way. We'll probably also see commercial groups sending up their own stations in the future. So our question was, in the next generation of microgravity research platforms, new ISSs or new smaller stations, who will be able to go? Because for now, it's not a commercial thing, it's operated by governments. So you can pay a company to help you get there with a commercial and government partnership, or you can go directly through the governments. So our question becomes, what's the future of access to this kind of research? So there's a news article and a paper you can read that we put out highlighting what's happening today, what's been planned for the next generation, meaning which companies are planning and which governments are planning next generation locations for this research, but also what are the possible risks or opportunities for new actors who haven't done this kind of research yet. What you see here is a big map, but our key idea is there's lots of organizations. We have in the room with us Dan Barstow from the ISS National Lab team. Welcome, Dan. You can talk to him if you want to find out how things work today, how organizations in the US currently can send research up to ISS. So part of our question becomes, how will the ecosystem look? Who are the players in the government side, the company side, and the education organizations that will all play a role? Our key question is, can every university have the right or the affordable access to send their own research to space in the future? It really should be something that any student could look forward to doing, especially if there's more venues to go to in the future. So we have this vision that there probably will be a combination in the future of some international multi-government space stations, some that are privately operated. And our main argument is that there should be at least some where governments are subsidizing the opportunity for research by university students. And there should be some places where the students don't pay the full cost of being launched to space, but through public-private partnership, there's still some access, just like we see today. But again, it needs to be planned and coordinated, just like we've seen through decades of coordination on the ISS. We don't want to lose that in our next generation. All of this, as you can see, is pointing to say, who gets access to space, and will it still be open to people from around the world? Now let me show you what microgravity research can look like. We have one project we're working on, and we're asking a question around wax. Now, wax may not sound like space technology, but my colleague, Dr. Javier Stober, did his PhD at Stanford. And it turns out about 20 years ago, that team discovered that common candle wax can be used as a propellant that can be used actually for rockets. So they've been studying this for a while, and I have to give credit to the Stanford team for this video. They're going to show you how it looks when you burn wax as a rocket fuel. Already very cool. So I got to know our colleagues there, and I hired Dr. Stober to work on my team, and I asked, well, people have been working on this for rockets, but I'm a satellite engineer, but can you also use this kind of fuel on satellites? This area is not explored fully yet. It's been studied theoretically, but not done yet in space. So we've been studying what happens to wax when you use it for fuel in space instead of on the ground. And one thing you need to know, this is just an example of how the wax looks. We need to find out how it works when it's a liquid and also in space. We want to see if we could actually manufacture this kind of fuel in space in the future. we are not getting to space yet. So we're starting with a cheaper place to do microgravity research. You can do it on a plane. And there's a company called ZRG Corporation that does these, they're called parabolic flights, where they fly their plane very steeply in the sky, like a roller coaster. And as you go over the top of the hill, quote unquote hill in space, you get about 20 seconds of microgravity. So my colleague Christine, who also did that report on how we need to spread microgravity to everyone, she has experienced the microgravity herself. And here's an example of her taking our experiment of liquid wax to find out what happens, how it behaves. She's doing very serious scientific research here, and I can see that she's enjoying herself. I just have to note that this particular video is from a day we were hosted by the United Arab Emirates Space Agency. You'll notice everyone else on the plane is from the UAE, particularly young ladies from their local high schools who are also doing microgravity research that day. We are collaborators with them, and they said, well, we have an extra spot on our plane flight. If you're ready to go in a month, you can bring your experiment. And we said, we'll be there. So we were lucky enough to fly with them, but flying out of Florida. We've been studying this question, and my colleague Julia is also a master's student. She's from Kenya, and she took our second flight. Each time we're trying to test what happens when you spin, it's called spin casting, liquid wax into a form that would actually work for burning in space. And so Juliet did our second flight, and she was lucky enough to meet Dr. Katie Coleman, who's one of NASA's retired astronauts and a mentor for our team at MIT. She's also doing our research experiment for a second time. And what we're actually showing is we're finding out how fast you have to spin the wax to get just the right kind of geometry. What you want is what you see in that 5-volt view. You want a very nice cylinder with a hole in the middle, which is the most efficient way to burn the wax when it's solidified. We want to find out how slow it can be and still get the right shape. So we're working on that. We'll get back to you with our results later. All of that is to highlight that microgravity research that leads to new space technology can be done affordably and inclusively. And so we hope to share this as a collaboration with other partners around the world. Let's move on to another topic asking, what are we doing now to apply space technology to the Sustainable Development Goals? Here, it's not just what we can invent in our own lab. Here we want to ask, what are people doing in their own countries and communities, and how can we join them? The first example is a big team collaborating from MIT and from NASA, from a company called Blue Raster, and from several collaborators in the countries of Ghana and Benin in West Africa. We're fortunate to have funding from NASA's Applied Sciences program. You may not know, but NASA spends about $2 billion per year on just earth science, meaning doing research, but also making applications, so results that come from the research for society. So we are proud to be a part of that NASA Earth Science community. Where one of our projects is focused in the area called Cotonou, a major city in the country of Benin, which is right next to Nigeria in West Africa. Cotonou is a beautiful city, and they are centered around a lake called Nokwe. And Nokwe is very important to the local economy. It's also a place where a lot of people live. Many people have their homes right on the lake, and they actually spend their day mostly moving by boat rather than by vehicle. They move often by hand-powered boats. I was lucky enough to be on a motor-powered boat because we were traveling to the lake and identifying one of the major hazards, which is actually an invasive plant brought in by colonists, which shouldn't be there. It's called the water hyacinth. It's beautiful, but it's also rather concerning for economic issues. If your main activity is fishing or moving around by human-powered boat, this could actually be a major concern and block you from those activities. So many people who spend their day doing market activities based on human power actually are blocked and can't travel effectively due to the plant during certain seasons. Now, thankfully, we met an innovative team called Greenkeeper Africa. They're a local company that had been working when I met them for several years to set up a technique to harvest this plant, and they actually use it to make a tool that can actually absorb local oil spills. So they take the plant, they dry it out, they bring it to their own factory, and they turn it into this fiber that has excellent absorptive properties. So this was their innovation. I just met them and heard about their great story, and they invited me to come to Benin. I told them, maybe space technology could be used for your business. I don't know, but please come and show me what you're doing. So I had my first visit to Benin in 2018. And the team there, you see the local company team, showed me their factory, they showed me the area where they're working. And we identified that one of their goals is to better monitor the seasonal growth of the plant. It has a few months where it's really active, other months where it's quiet. And also to be able to count how much they're harvesting and how much they're removing and benefiting the society. So I identified a plan to build a network and to use data from satellites, from drones, from planes, as well as from sensors right in the water, so that they can have scientific measurements about what the plant's doing and how it's affecting water quality. We also got to meet local scientists from the universities that have studied everything there is to know about this lake and they're sharing their results with us and giving us advice on how to best collect the data. So we're now building data sets that they're using. Here's an example where actually what you're seeing here is a satellite image from our European space agency partners who often publish free data, and this is from a system called Sentinel. Now, there's a trick here. All the red is actually vegetation. So red means green, and blue means water. So we do it this way just to get a more visual view. But wherever you see these areas with a blue background and the red, it's actually big clumps of this plant just growing. We can actually see it from space. In this picture, 1 pixel is about 10 meters. So if you zoomed in, the smallest thing you would see is a 10-meter box. Another way to look at it is just to take a graphic, but to take the data where we know we've seen the water hyacinth plant and show it on a map. We want to make maps like these easy for our colleagues to use. They don't have experience with data from satellites, but they know how to take this information and apply it to their business activities. One thing we've done so far, one of my colleagues, his name is Ufoma Ovimhada. She is a master's student, and she has worked with one of our NASA partners, and they've now done a historical analysis. What you're seeing here is multiple years, about 5 years of data, showing exactly how much of the lake was covered by water hyacinth in terms of area every year for each of those years, all looking from historical satellite data. So it's the first time this company has had the exact measurement from a global view or regional view of how much has been there. Another challenge in the area is that there's a local practice to create fishing farms, which are useful to increase access to fishing. So these are areas where people set up fences and put nets around them and grow fish and protect them from predators. But it also creates a concern for water quality, and it attracts the plant, which is happy to grow where the fences are added. So we are also asking, can we use radar images? This is a radar picture where you send a radio signal down, it bounces back up to the satellite, and wherever you see these square shapes, you're seeing the lake with these fish farm areas marked off as squares. So we can also count how much area is being used for fish farming, but also ask, is it too much to affect the health of the water? One biologist told me the other day, it's like, well, the more fish farming you have, the more you're depleting the oxygen in the water. And if you do that, eventually you can't grow more fish. So you have to really ask, is it the right amount for the health of the lake? So we're basically offering these tools so local people can decide how they want to manage their own area. And here's an example of using satellites, but also drones. Take a view, so here's a view from the drone of looking down on the fish farms. This is my colleague Ufoma. She's practicing with an experienced pilot learning to fly the drones. And eventually we'll have a website like this, which we're prototyping along the way with our colleagues from Benin. It'll eventually be a dashboard they can go online and they can check from their home, but also as they go out to the lake, what are they seeing and what's changing and what's been happening over the weeks with the water hyacinth, with the fish farming, and with the overall water quality. So we're excited because this is a team that usually wouldn't use satellite data, but they can see the benefit and they're working closely with us to co-design a system. In similar ways, we have other projects in places like Brazil and India. These are our colleagues, Jack and Miles, who are working on using a system of complex system models. This just means fancy engineering models to answer questions. We have a few questions to ask in Brazil. We're asking what's happening in the environment, how does it affect people, and how are government teams making decisions around how to change it, and which technology should they use. So in this case, we're working in a beautiful place. We do enjoy our travels to work on our projects. It's usually to a place where we'd love to spend more time. This is Rio de Janeiro in Brazil, and the government team in that city has a great team focused on using data from satellites and any other source to help improve city management. So Jack has been lucky to work with a local university and the local city government. They're concerned about mangroves, and a really important type of tree that provides contributions to biodiversity. But you can also see them from space and see where they've been increased or decreased due to human activities like building new homes. Now, if these trees are healthy, the community around them is healthy. And in Brazil, but also many places around the world, people who live near mangroves are often the poor who depend on having healthy fisheries to catch fish and crabs. It's a main part of their livelihood. But they also may have a reason to cut down the trees to get firewood or housing materials. So they have a tension, cut down the tree today and have firewood, or leave the tree there to have long-term fishing. It's kind of a challenge for them. So the city wants to coordinate with the local environment teams. And these are students from the local university, and they are hosting my student Jack, showing him what they're doing to study the local communities and the trees. And we're working together with them to build these new models to understand what's happening using data from satellites and also from the ground. Another example then is looking at what's happening in India. One of my students is Neil Gaikwad, and he brings his work both to build models, but also to really ask how technology either does advance justice or makes it more difficult for people, especially those who are economically and disadvantaged, to make their goals. So in this case, Neil Gaikwad, he's a computer scientist, but also very concerned with justice, especially for farmers in India. He's thinking about how we can use data from satellites, and then the tools for machine learning to help us organize what the data means. And then he thinks about economics and how do we design markets, but also kind of the rules guiding things like insurance to make it easier for farmers to meet their goals and have successful farming and income. This is an example where Neil's been working in one of the areas in India where he grew up. He's trying to understand the needs of farmers and what size their farm scale they are, what they're kind of planting, and what they see as major threats to their success. Things like floods, sometimes drought, but also just access to local water based on local government policies or issues of pests. He's been traveling around among the communities and talking to people in their local language to find out what are the things that farmers worry about. Sometimes there's concern about rashes of farmer suicide when there's years with very difficult farm outcomes, when there's crops lost due to natural disasters, or when there's a lack of insurance to cover farms. People actually often are overwhelmed by the economic uncertainty. He wanted to find out how could more information help them avoid this kind of challenge. So this is Neil talking to several local farmers. He's now building a system which will be a mobile app because he's been exploring how to use satellite data to look at issues like water access and crop health. But you want to compare that satellite data with data from the ground. So our next phase will include building systems to help farmers share their information with us directly from their own phones. I want to also highlight the work of Pratima Muniappa, also a student in our team, and she's also originally from India, and does a lot of her work with communities that have lived in harmony with nature who actually know what sustainability looks like. They're people who are not causing long-term harm to the environment. Many of them are indigenous communities who live in forests. We're first asking what we can learn from them about space itself, because every society has developed over the years their own cosmology, meaning their own study of what happens in space. And so Pratima's been visiting teams, most recently in Chile, and talking to communities who are sharing with us their ancient stories and their ancient knowledge about the sky. Many communities that we don't have all of it now, but many communities throughout history have told stories to each other that helped explain the movement of the stars. And for example, in the area of the Atacama Desert in Chile, where many international telescopes are operated, that same local area is a place where communities who live there had their own constellations. Instead of being the stars, they were actually the dark places of the sky were the constellations. And they were able to decide how to raise their herds of llama based on the passage of the stars and the constellations over them. So they had really deep knowledge of the universe, which we often don't compare with or use next to our knowledge from science. So Fatima is listening to people and sharing and making documentaries about this topic. She's also visiting communities who live in forest, especially those who have found ways for humans and plants and animals to live in a very sustainable way. This particular example from the Kasia people in India, they have a beautiful technique of working with tree roots. And they turn these roots actually into structures because their area where they live is a place that's difficult to navigate without bridges, but they build the bridges directly from living roots. They don't destroy the trees, they actually allow them to grow in a way that makes these structures. This is one example of a unique kind of knowledge that could be lost because many communities that live in forest are being somehow threatened, meaning either the deforestation of their area is a concern, or there's government policies that cause them to not be able to stay where they are, or just people have moved from their society, so they don't have all the knowledge retained. In response to this, Fatima is building a system. It'll include data from satellites and geopositioning from satellites, but also just a chance to do interviews and make videos with communities and ask them how they'd like to record some of their knowledge for their own next generation, as well as to share with the world. So she calls the system Scribe, and I'll show you a demo of how it will look when it's ready. So Scribe will be, in this case, a mobile app that Pratima, as a researcher, or other scholars could use, but also she's coordinating with a local videographer from this community who's going to make their own stories and archive them in this way. And it's a way to both create stories about what's happening, but also include some technology that makes it slightly more safe in a way that helps avoid the data being shared or stolen from people outside. How are we doing on time? About 5, that's great, that's perfect, excellent, we're doing wonderful. So what I appreciate about Fatima's work is that she has a great respect for the community she works with, and she finds ways to ask their view and their permission before she makes a design choice. And so that's really the ethos of what we're trying to do, is to ask, how can we learn both from their natural knowledge of the environment, as well as from their guidance on how to be best advancing justice in each technology design choice we make. We've talked a lot today about Earthrise. We had in our own team a celebration of what's happening this year and looking back at the 50th anniversary of Apollo. Our celebration came in the form of art. I mentioned that several of the team members are practicing artists and designers. And so in particular, I want to highlight Lizbeth Barrios de la Torre and another team member named Rachel, who was left us previously. And they were thinking about Earthrise and drew this picture actually last year to say, well, what if people could experience what the astronauts experienced when they looked back on Earth and reflected differently about our humanity and our shared location? We wanted to imagine a place where people could do that without actually traveling to the moon, and a place where they could reflect about issues of climate and about our shared global voyage on this spaceship Earth. We had the opportunity to be invited by the Intrepid Museum to be a part of their celebration of the 50th anniversary, and they allowed us to actually make this vision a reality. So what you see here is we were in the room on top of an aircraft carrier, which is one of the locations where one of the NASA shuttles has been retired. So you know that a number of museums around the country had the chance to host the retired shuttles, and the Intrepid Museum of Sea, Air, and Space is a retired aircraft carrier. It has a shuttle on the deck, and it's amazing just to be there and sort of see all these planes, but also appreciate that you're on a boat in the water. We spent a couple of days there, and we were in this room where they've hosted the shuttle. And we had a chance to add our own small display for 2 days. And this is my colleague Liz and my colleague Kate. They're setting it up. We actually want people to sit on a bench and look back at the Earth and remind them that we were celebrating literally on those days of July 19th and 20th, looking back at Apollo. After our setup, it looked about like this. It was a dark room where you could go and just sit quietly. Some people asked me, hey, is the video working? I said, yeah, it's working, just sit there. All we want you to do actually is to think about how you feel about the Earth if you had a chance to look back at it and watch it rotate slowly and think about your home and your place on that planet. One of the colleagues in my team is David Colby-Reed, and he is a designer and he studied cognitive science. In our work now, he's bringing together questions from philosophy, from ethics and law. Earlier, we heard some ideas about how it might look when people start to live full-time in places like the moon and Mars or asteroids. And David has a concern to bring to all of us, asking, are we going to have technology, but also just the locations, because it's so dangerous to live in space? It means you actually have to have technology that keeps you safe, but it's also very regimented. If you're an astronaut going to space now, you have to follow a lot of rules, careful what you're wearing. You can't just go and do whatever you want. So he asks, does that mean our societies will also be very regimented, meaning in order to keep everyone safe, you also have a lot of strict rules? So his question for his thesis is, how do we actually create democracy given the limitations of what you can actually do and not do in space? He'll be spending the next couple of years, hopefully, asking this question and talking to ethicists and lawyers and philosophers, because we don't yet have the answer. For all the students in the room, I hope that you can take this question to heart. We'll need you throughout your education, and when you become leaders and adults in the future, to help us answer these questions, because when you're working and getting paid one day after your graduation, these questions will still be on the table for all of us. How do we design societies that actually are, perhaps ideally, not taking all the mistakes we've done on Earth with us? How do we bring that knowledge also back to Earth and make a difference here? So I hope you'll celebrate with me these work with the students and share your questions. I'm looking forward to it. Thank you so much.
So we'll now take questions from the audience, and a reminder, those of us who are joining from Zoom can also use the chat feature.
Yes, you said something about social science, right? So what's the function of social science in space, like psychologists, what they will do in space?
Thank you so much. So the question was asking, what's the function of social science in space? And I'll also bring it back a bit to our own group. So I showed examples of projects, right? We're working in Benin and Ghana, and Brazil and India. So one thing for us personally is that when we start the projects, we are already applying or drawing from social science. So before we as engineers and scientists and social scientists start projects in collaboration, we are checking papers and reading what's been done already, the history of those areas, understanding how sociology or political issues are affecting our plans. So that's one piece, is that we want to see close collaboration between the knowledge and the insights from social science with technology designs. More broadly, you're right, though, that there is a bigger question as to the role for society in general of social science to think about how we design future life in space. And of course, it's great. I mean, there's lovely collaborations already between universities and space agencies. People run interesting simulations to ask, how people live and work as teams in space. I'll highlight the work of a professor at the University of North Dakota named Pablo de Leon, originally from Argentina. He now lives in North Dakota, where it's a little different weather than Argentina. But he specializes in asking around the kinds of behavior human teams might have when they live, for example, on a moon base. He actually brings his graduate students together to live in moon bases, meaning a small camper in the snowy winter of North Dakota. And they actually practice what we like. And they're partly bringing in psychology as well as physical questions. And they're kind of watching the dynamics of the teams, not just them, but many others do this kind of experiment. So that's one piece. But I think in a broader sense, we've not finished designing not just the behavior of one team, but the behavior of a community or a new government form that might need to be designed. I do think someone referenced earlier that social scientists and actually science fiction writers have done a lot of the imagining of how people might live and work in space, but there's plenty of work to be done to take the technology we understand today and the physics we know about places like the moon and Mars and really start to then extend and have debates and have more simulations to ask how should we design society, which includes the regulation, the policy, but also the kinds of norms and culture we want to build. I think there's plenty of exciting work to do, and I look forward to seeing some of you do it.
Thank you for a very, very provocative and interesting keynote. And I really liked your last question about thinking of what it would take to live in space. And I want to invite us all to think about turning that around. And what if we think about how do we live here on Earth if we recognized that we're all dependent on one another and each activity affects one another, the way it would in space, and how might that contribute to Earth sustainability?
Thank you so much. I think one of the tensions we're trying to draw today is to say, an earlier speaker was asking, if we're designing life in space, does it mean we're trying to escape Earth? So in our group, definitely not. Our ethos is always to make a circle between inspiration we draw from space and hopefully new ideas and bring it back. It's also, of course, to learn. I mean, part of what we do regularly is to look at history of the Earth. So I teach a class every fall, and I invite all of my students in the class to read a very long history book. In this case, I want them to think about injustice on Earth so that they are able to then really in a concrete way start to ask, how do you design for justice after understanding how humans have created great injustice? The book we read that's the longest, it's one of several, is by Dr. Ibram Kendi. It's called Stamped from the Beginning, and the subtitle is The Definitive History of Racist Ideas in America. Now, I'm a space engineer. Why do I assign my students to read a history about racism? The reason is that racism is one example of a very long-term systemic feature of human society, particularly in this case, a connection between links of economics and social and colonial relationships between Europe and the US and Africa, and also other parts of South America. The book covers a 400-year history and really lays out in a very well displayed and well articulated way exactly the role of racist ideas that were used to justify economic choices. The argument in the book actually says that in this case, people wanted to make money. They found that in this case, either enslaving or colonizing people who were darker was a good way to make money. They didn't have originally a real concern about the color, but they thought, well, if we can label people who are dark as subhuman, people won't mind if we enslave them and colonize them, so that sounds good. We'll use racist ideas to justify this. And it's led then to entrenched racist ideas that continue today. So as we look at Earth, we first ask, well, how has that already affected people's access to technology from space today? Then we can ask, how can we sort of avoid that kind of design in space in the future? Then we can come back and ask, how can we also continue to fight that issue on Earth? So we see it as a circle of both understanding history on Earth, taking inspiration from space, but always bringing it back to Earth. And hopefully that circle continues. So thank you for asking.
Okay, we have a question from someone who's joining us via Zoom.
All right, it's someone you know well. David Kendall has a question for you.
Thank you, David.
First of all, he's very excited and enjoying your presentations very much. David has this to say: your work very effectively brings together the public, private, and academic sectors. What are some of the challenges with trying to get these three solitudes working together?
Thank you, David. Thanks for staying involved, and I hope you enjoyed the COPUS simulation. We'll see these ladies out there in COPUS in a couple of years. Now, it's a great point that I'll highlight the secret behind the question is I made an effort before I had this job to work in academia and government and industry. I was personally curious about the sectors. I was curious about what it is that makes each one operate differently and what the incentives are. So I did some personal research, you could say, by working partly at NASA, at a company, at other universities. So I bring that to the table. I think what's great is that when each team does their strengths, then you really see a lot of power. I can show a bias that I really appreciate when governments invest in fundamental research and enabling infrastructure that allows other groups like universities and companies to be effective. I think it's really exciting when companies are able to experiment with novel capabilities and kind of novel business models, but also kind of leverage public investment. I think it's great when universities can be like a nexus for dialogue and for kind of open relationships that are not driven by profit. So I think we do see that in many cases, but we need to see more. A great example is a group called the Group on Earth Observation. They're an international body, and they have members who are countries, but they also recently invited companies to be members at the associate level. So they can have dialogue about what designs we need to take data from satellites to observe the Earth and then use that to make a difference in everyday lives. Another cool example is actually satellite navigation. We all have phones that can receive signals from satellites operated by governments. So the US government, Europe, and also Russia and other countries, and they're operating these as public utilities, and then companies create markets, business models on them, and then you have users like us who get to use them in our daily life. So that was actually not planned to be quite that effective. It's working better than we thought. I think we can then learn from these historical examples and then ask, what are the next generations of these kinds of utilities with supporting businesses and then public interaction? So I think there's plenty of examples to learn from, but we haven't tapped all the great examples yet. Thank you, David. I'd love to get a question from a student if we haven't already.
Questions? Okay.
All right, that's wonderful. Thank you, students. I see students fighting over which one should ask the question. That's good.
Hi,
Hello.
I'm a student. I was wondering, like, I don't know, the actual viability of like waste disposal in like space and like whether that's a good or a bad thing in your opinion. I'm just curious to hear your thoughts.
Thank you so much. The question was, what's the viability of waste disposal in space? A couple layers. What we know right now, what works right now, is if you were to operate your own satellite in space and you operate it in an altitude that's not too high, so between 100 kilometers up to like 500-600 kilometers, it is possible to make a plan without too much effort where you operate your satellite in space for a while, and actually, naturally, it'll come back and be destroyed without much additional cost. Meaning, if it's not too high and it's exposed to some of the actual remnants of the atmosphere, as you get farther up, it gets thinner, but there's still some particles there. You can get some benefit where actually your satellite can deorbit naturally, and then it comes back toward Earth, and it's a very small object compared to the ones that we heard about earlier. And generally, these objects, when they're smaller, are destroyed naturally in the atmosphere, which is a good deal for us. There's other cases, though, where satellites are operating higher, farther away, or where they don't have the ability, due to them carrying fuel, to kind of come down quickly. People debate, for example, how long should a satellite be in space after it's done? If it's a 5-year mission, should it be there for 5 more years, 10 more years? Right now, the best common thing we do is usually about 25 or 30 years. So part of the question is, how long are we waiting for waste disposal? There are various companies that have ideas now that they could sell you a service. They could go pick up your satellite and bring it down faster with their extra fuel. Or you could plan already when you launch that you're going to make sure that at the end of your mission, you have enough fuel to do something very careful and come back down. This is actually a hot topic for both research and for policy right now. And the other question is it all waste? Meaning, there's actually a lot of useful aluminum and other parts in these spacecraft. We have not really effectively done recycling or reuse of objects in space. Objects in space are going very fast and they're difficult to harness, but it's not totally impossible to consider somehow retrieving existing objects. So I think if any of you are thinking about entrepreneurship and you have ideas that blend physics and business, there's still some untapped ideas. But I think the goal too is to invent new ways of operating satellites in the future so that instead of planning to use things once, we can imagine reusable things or shared resources there so we create less waste as well. But there's plenty of new research to be done in that area, so please join us. Thank you.
One quick question because we need then to move on.
Yeah. I vote one of the ladies from Girls Inc. should speak. Love to hear you. Thank you. Please stand up.
So basically my question is, what do you think the government's intake is about like sustainable energy? And like on the news, like some of the politicians don't really support things about space. So what do you think the sustainable energy, like how do you think they will react to it?
Thank you very much for the question. I think you're talking about the US in particular, is that right? What's happening in the US government? Let me just give you some background information. So I used to work for NASA, so I can just caveat that with a bit of a bias. And right now, NASA's budget is about $21.5 billion per year. Big number. One of my students last week did an analysis. We were comparing different agencies and looking at kind of how NASA's budget compares to other things. So we're not the biggest science research organization. That would be the National Institute of Health. They spend more money, but of course, really important to study health. And we're not the smallest either, kind of in the middle of science studies, but we're also a much smaller percent of the overall US government. So I'd say on one hand, we can be proud that the US has spent a lot of funding on basic research and development in energy and in space and in health for decades. And then on the other hand, of course, young people who have an opinion can prepare to vote or prepare to kind of call your congresspeople if you think you want your own representatives in Congress, but also at the state level, at Massachusetts state level and local level. If you think that they should be spending more money on scientific research, you should call them, literally, because we have a chance here where there's a voice that you can play. Maybe they're interested in whether you and your colleagues are interested in that, and that could shape how they view. So I think we do need to see more citizen pushing for saying that they appreciate the benefit of this kind of research, because that'll help us in the future. Thank you.
Perfect. And I think with this, unfortunately, we need to end the Q&A, but I'm sure there will be more opportunities. So let's thank Dr. Wood again.